Hi, my name is Peter Cho. I'm a research scientist working in the area of computer vision at Analog Devices. Today, I would like to talk about how time-of-flight sensing can dramatically alter the landscape of e-commerce and literally bring the full shopping experience into your home. First, let's simply describe how time-of-flight or TOF sensors work. By emitting a pulse of light and measuring how long it takes that pulse to reach the object and reflect back, a time-of-flight sensor can calculate the distance to that object in the scene. Now, working in partnership with Microsoft, which is a world leader in time-of-flight sensing, ADI has released the highest resolution time-of-flight sensor, which is called the ADI-3100. With a 1 megapixel resolution, the highest modulation frequency on the market, and a tiny pixel size of 3.5 by 3.5 micrometers square, the ADI-3100 can produce the most accurate depth image with the least amount of power consumption available today. In order to take full advantage of this sensor, we have also developed the ADI-3000, which is the corresponding laser driver needed to reach high modulation frequencies up to 300 megahertz. These two products are used in the research camera shown here. Now, this is a prototype unit, so we're using this basically for developing algorithms as well as collecting data, but it contains the basic key components. The time-of-flight sensor itself is located near the front of this particular unit. There is a battery which allows us to use this unit as a standalone self-contained device, and then on the backside there's a small screen where we can see the output from the camera after it's processed by this onboard computer. Accurately measuring and dimensioning objects in three-dimensional space is an important capability in many different commercial and industrial markets. Here, we're going to focus upon dimensioning boxes, and in particular, we want to measure their widths, lengths, and heights as accurately as possible. Since boxes are very symmetrical, we can calculate their dimensions from a single time-of-flight frame. As this video clip illustrates, a user can simply aim a time-of-flight sensor at a box sitting on a flat Z-plane like a floor or tabletop. The user then presses a button to request the dimensions of the box target. In less than 2 seconds, an edge computer processes the input time-of-flight frame to determine the dimensions of the box. If a box is detected, its three-dimensional dimensions are projected into the time-of-flight image plane. Time-of-flight imaging can be used in the future to enable a new type of shopping experience. We'll start at the warehouse where your purchase is being packaged and shipped. Time-of-flight cameras can quickly dimension objects so that an appropriately sized shipping box is picked for your product. No more waste by receiving a tiny object in a very large box. Additionally, the shipping fee for a box can be based upon its size rather than set at a flat rate. In the future, new e-commerce concepts can be extended into your home. Beyond boxes, a time-of-flight camera could dimension you. By knowing your exact shape and volume, e-commerce sites can suggest the most appropriate size for your clothes or dress you up in a virtual you in a new type of fitting room. A time-of-flight camera can also be used to accurately map your house. In the future, time-of-flight imaging will enable augmented reality customer experiences that will show you exactly how a piece of furniture would look or how it would fit into your home. By utilizing 3D data, we can create maps far superior to those available today based upon simple two-dimensional cameras in phones. I hope this gives you a glimpse into an exciting future world of e-commerce enabled by time-of-flight sensing. Thanks for watching this video. To learn more, please visit analog.com/TOF.